Hello, check. Alright people, I believe we are live. Welcome to Catalysis by Vedantu. My name is Pahul, and if I'm audible and visible, please write here in the chat box, you know the drill. Yes. So people, today is yet another class of electrochemistry. Now a few things before I begin the class. The first thing is that I have noticed that the number of people watching these classes day by day are decreasing. So what I've decided is that I will make every class a little shorter. Okay, what that will do is it will increase the percentage watch time of the class. Okay, and that will tell the YouTube's algorithm that this video has to be recommended to more people. I hope you understand that since this is a YouTube channel, views are important for a YouTube channel, है ना? तो इसीलिए I will try to make these classes a little shorter, okay? But since we are having 5 classes in a week, covering the syllabus on time should not be a problem. And since I am doing shorter classes, let's try to do it today. And if that is possible, then you will get a little more time for self-study every single day. Fine. So just telling you that idea. Now, in the previous class, what we had done was we had learned about conductivity and conductance. Yeah. Today we will build onto that idea. We'll see how if we take a solution and we dilute it, what is the variation that we see in conductance and conductivity. Those ideas, very important ideas, and those ideas are more important theoretically than mathematically, because questions from the theory part, questions from the basics of theory part can directly be asked and they can be confusing as well. Cool. So इसीलिए fine. We shall do that today theoretically. And one more thing that is associated with the dilution is Kohlrausch law, and Kohlrausch law is something that we will cover in tomorrow's class. Fine. So by tomorrow end we will be done with all the part of this chapter which will come in the examinations. Later on, electrolysis, Faraday's constant, etc. will remain, which is very easy, and batteries will remain, which will be a part for your self-study, which is also very easy. Chalo. अब आगे बढ़ते हैं. This is the homework question that I had given you. Yeah, the electrical resistance of a column of 0.05 moles per liter NaOH solution of diameter 1 centimeter and length 50 centimeter is 5.55 into 10 to the power 3 ohms. Calculate its resistivity, conductivity and molar conductivity. So I'm pretty sure you guys know how to do this particular question. You know that resistance is equal to resistivity into L by A. This is your cell constant. Now resistivity can be written as 1 by kappa. Kappa is your conductivity, yeah, and resistance can also be written as 1 by conductance. So conductance bhi aa jayegi, resistance is given to you. Let's see what is given to you. This is given to you. So if you have resistance, you can easily measure conductance as well, but I don't think that's asked in the question. तो भाड़ में जाए. Yeah. So from here you can calculate. Fine. Resistance is given. Length is given as 50 centimeters. Area, diameter is 1 centimeter. Yeah. So area is what? Pi r square. R is given as 0.5 centimeters, isn't it? So from here you can calculate cell constant. If you have R, if you have cell constant, you can easily calculate the conductivity, you can easily calculate the resistivity. Yeah, ये आ जाएगा. So then you have to calculate molar conductivity. As I told you that kappa is for 1 cubic meter. यहाँ पे since the cell constant is in centimeters, the kappa that you calculate from here will be for 1 cubic centimeter. So this kappa is for 1 cubic centimeters. You have to calculate what is the, ठीक है जी, you have to calculate what is the volume of this entire thing. L भी है, A भी है. You will calculate the volume of this entire thing and then figure out what is K for that particular volume. Okay, simple सी बातें हैं, काफी you can calculate it for this volume as well. If you want to calculate the molar conductivity, how will you calculate it? This many moles per liter. So 1 mole is in how many liters? You have to calculate the kappa for that. Yeah, K is for 1 cubic centimeter. Convert that to liters, you'll get the answer. So let me show you the solution of this. It's an NCRT question, काफी simple सा question है. So these are the answers. Yeah, conductivity is 0.01148 S per centimeter. Molar conductivity is 2 to 9.6 S centimeter square per mole. और कुछ बचता है? Pretty much. We're done. Okay, so you can calculate the values in terms of meters as well instead of centimeters. दो अलग तरह के solution दिए हुए हैं. It's given in the NCERT straight away, and then the formulas that you are going to use are pretty basic. So let's see how many of you gave the correct answer. Time for the Hall of Fame. है ना? एक बार खोलता हूँ मैं previous class and let's see how many of you actually gave the correct answer. Okay. Here we have it. अच्छा जी, तो resistivity कितना है? चलो conductivity से पता लग जाएगा. Sairam, yes, I believe your answer is correct. Very nice. Sairam's answer is correct. I think Murli's answer is also correct. हाँ जी, बिल्कुल सही लग रहा है मेरे को तो. Yeah, I am just quickly checking these answers. I might just miss some units, so if your units are incorrect, you can check it out over here. Shubhiksha, yes, that is correct. Very good. Teja, yes, Tejo, yes, that is correct, man. Sangeeta, you missed the units over here, but okay, your numbers seem to be correct. Janvi, that is absolutely correct. Bindu, that is correct. Pankhudi, that apne meters mein nikala hai answer. Yeah, so that should be correct. Very nice. And Lekha, all values in SI units. Okay, if you say they're in SI units, then your answer of conductivity might. एक बार check कर लेना, Lekha. Just check your answers once. Not sure. Rishi, okay, that's correct. यहाँ पे you missed the units as well. Kalpana, Bunny, Rucha, you guys have given almost the correct answers. Rucha, थोड़ा सा यहाँ पे you could increase your accuracy, but overall I think you've done a pretty good job. Savan and Sanjana and Rishi, everyone has given basically the correct answer. Maybe one of you or two of you have jumbled up the units, but please take care of those units eventually. चलो अब आगे बढ़ते हैं. Now is the time for us to move on. देखो अब हो क्या रहा है. Let us think of one particular cell. This is your conductivity cell. Fine. And as I told you, it has these electrolytes which have a fixed certain area. Yeah. And you know the length of the column. You know the length, you know the area. So this particular cell has a fixed cell constant. Now what we'll do is, we will fill this up with some electrolyte. Let's fill this up with the electrolyte. And what we can write over here is that your conductance is equal to conductivity into L by A. Now in this particular situation, this value is a fixed value, isn't it? This value is a fixed value. Now, what if I dilute the solution? Dilute it. How will I dilute the solution? Diluting the solution basically means adding more solvent. So what I can do to dilute the solution is I can take out some of the solution which has the solute dissolved in it and put more water. Dilution basically means reducing the concentration of my electrolyte. Is that correct? Do you understand? By diluting, you are reducing the concentration of the electrolyte, isn't it? So, my dear friends, from this statement, can I write? मैं यहाँ पे लिख रहा हूँ. Okay. From there, I am continuing over here. Can I write? There is less electrolyte per unit volume. क्या मैं ये बोल सकता हूँ? Isn't it? I am diluting it. I am basically reducing the concentration of the electrolyte. So therefore, it implies that there is less electrolyte per unit volume, isn't it? Yeah, cool. Jeswin, it'll take time for me to come back to the chat. So if you've got anything, you can ask me now. Sarvajna, thank you so much. I'm sorry I can't pronounce your name correctly, I guess. Sarvanya, I don't know. It's a confusing name for me. Sorry. But thank you so much, yeah. Sam, as I told in the beginning of the class, Kohlrausch law I will do tomorrow. Today we will just theoretically discuss what happens on the dilution of electrolytes. Madhu, cats are in the room. ठीक है, बोर्ड्स के लिए कुछ नहीं पढ़ा और टाइम वेस्ट हुआ है सर, क्या करूं? सक्षम, read NCERT, solve NCERT questions that will allow you to prepare for boards, and it will also allow you to prepare for JEE mains or NEET, whatever exam you are targeting. Okay, Lilac, not a problem yaar. Chalo, so this is fine. There is less electrolyte per unit volume. My dear friends, if the electrolyte is less, what is happening over here? Yeah, what I'm doing is less ions in this cell, isn't it? When I dilute it, concentration reduces, which implies that there is less electrolyte per unit volume, which means that in this fixed volume of the conductivity cell, there are less number of ions. So because ions are less, do you realize that the conductance will go down? Right, yes or no? Since there are less ions inside this conductivity cell, do you realize that this conductance will go down? Yeah? This conductance will go down, and if the conductance goes down, obviously conductivity also goes down. So my dear friends, very simple idea is, on dilution, conductance and conductivity, they go down given that the cell is fixed. Okay? If the cell volume is fixed, then ये भाई साहब कम हो रहे हैं. Okay, so I can write over here conductivity. Okay, conductivity reduces with dilution. Very simple idea. Okay, this is the simplest of idea that we will discuss today. Less ions, less conduction, less conductivity. But now there is a very interesting graph that I will show you. Before I show you that graph, I would remind you of what is molar conductivity. I'm going to erase everything on this page, so pause this video over here if you want to see this page a little further. अब सीधा बात करते हैं molar conductivity की. Yeah. So my dear friends, let's say you've got an X molar solution. Let's try to figure out a formula over here. Let's say you've got an X molar solution. So kappa is conductivity, yeah, for, let's say we are dealing with meters. Okay, let's say we are dealing with kappa unit being S by M. Okay, so conductivity for 1 meter cube of solution. Can I say this? This is something that I had explained in the previous class. Kappa can be thought of as conductivity of a unit volume solution. Fine. ठीक है. This is the, यहाँ पे सीधा लिख देना है, conductance लिख देना चाहिए इसको. Kappa is the conductance for 1 cubic meter solution, because this is the conductivity. Yeah. Kappa is called conductivity. It is as good as conductance for 1 cubic meter of the solution. Now, 1 cubic meter can be written as 1000 liters of solution. Now let us look at the solution. अब इस solution पे focus करते हैं. Same thing that we did in the previous class. If I've got X moles in 1 liter, yeah, I have 1 mole in 1 by X liter, isn't it? ठीक है. So 1 mole is present in 1 by X liters of the solution. So to calculate molar conductivity, I need to create 1 by X liters over here. How do I create 1 by X liters over here? Let's just do some unitary method once again. फटाफट से करेंगे इसको. So I can write over here kappa by 1000 into 1 by X. Yeah, is conductance for 1 by X liter solution. And what is 1 by X liter solution? 1 by X liter solution is as good as 1 mole of electrolyte. Same thing that we did in the previous class, just revising it for you. So from here I am getting, this is for 1 mole of electrolyte given SI units. Okay, we are assuming that kappa over here is in S by M. ठीक है, meters assume कर रहे हैं यहाँ पे अपन kappa के लिए. Fine. So that is what you have to keep in your mind. Understood? Fine. If this was in centimeter, then it'll look a little different. The formula will look a little different. ठीक है. So my dear friends, what is X over here? X is basically your concentration. Yeah. X is basically your concentration. अब मैं यहाँ से सब कुछ हटाने वाला हूँ. I'm gonna erase a few things from here and I will show you something interesting. Can I say that molar conductivity, lambda m is molar conductivity. Okay, conductance for 1 mole of that electrolyte is called molar conductivity. Can I say molar conductivity is proportional to kappa by X? X is what? Molarity, concentration, है ना? Can I write this? X की जगह मैं लिख देता हूँ C. Same thing. Okay, basically this is equal to K by 1000 into X. X is your concentration, kappa is your conductivity, you know that. So I can say that molar conductivity is proportional to kappa and concentration in this particular manner. Do you agree or not? Isn't it? Yes. Now from here it means, okay, अब सोच के देखते हैं. If I increase volume, I just learnt, okay, अगर volume बढ़ाऊंगा तो क्या होगा? How am I increasing the volume? I am basically diluting the mixture. Yeah. How am I increasing volume? I have a mixture already. I am just putting more water into it. That's how I am increasing the volume of the mixture. So basically, if I increase the volume, basically I am diluting. If I dilute a solution, do you realize kappa will go down? I just told you this on the previous page. And also at the same time, concentration will go down. That's what dilution is, isn't it? So in this particular case, okay, for lambda molar, that is molar conductivity, kappa goes down, C goes down. Will lambda molar go up or go down? Yeah, if K decreases, lambda molar decreases, but if C decreases, lambda molar increases. है ना जी? Direct proportionality, inverse proportionality. But both are reducing at the same time. So will lambda molar increase or will it decrease? Think about it. It's weird, isn't it? Molar conductivity, will it increase? Will it decrease? Think about it. My dear friends, the observation that I'm going to show you now is really amazing. काफी मजेदार चीज है. The conductivity for 1 mole of electrolyte, conductance बोलना चाहिए उसको, it's just called molar conductivity. Conductance for 1 mole of electrolyte varies with concentration like this. This is the graph for molar conductivity of CH3COOH and this is the graph for molar conductivity of KCl. What is happening over here is, okay, at the bottom you have C raised to the power 1 by 2. Why do we have this 1 by 2? I will tell you very soon. There is an equation that we need to remember in some time. Concentration raised to the power 1 by 2. Basically, when you are going in the left hand side direction, okay, when you are going in this direction, you are diluting it. Okay, you are diluting the mixture as you are going in the left side direction. Can you see for both CH3COOH and KCl, when you dilute the mixture, the molar conductivity increases? Why is it changing differently for CH3COOH and why is it changing differently for KCl? We will understand after some time. Yeah, Kohlrausch law will also help us explain that. Ostwald's dilution law will also help us explain that. But for now, what you can see as a common thing in both these cases is molar conductivity. Okay, conductivity for 1 mole of the electrolyte this guy increases with dilution. Okay? Let us understand this mathematically. Let us satisfy our curiosity mathematically, and then theoretically I'll also try to explain how you can logically explain this idea. ठीक है? तो चलो पहले तो आता है lambda molar is proportional to K and lambda molar is inversely proportional to concentration. Now in dilution both of these things are reducing, है ना? But overall lambda molar is increasing. This guy causes an increase in lambda molar, isn't it? And this guy causes a decrease in lambda molar. So what it means is that the decrease in kappa is compensated by the increase in volume. Yeah. Can I just do this? Can I just say lambda molar is proportional to volume? Concentration is what? Yeah. Concentration is equal to moles per liter. Number of moles is fixed as 1. Isn't it? Number of moles is fixed as 1. So if concentration is increasing, liters are decreasing. If concentration is decreasing, then definitely liters are increasing, isn't it? Because the number of moles I have fixed to 1. Molar conductivity, yeah. So if I am diluting, I have taken 1 mole of electrolyte. Initially 1 mole of electrolyte was, let's say, in 1 liter. Now I keep diluting it. Now 1 mole of that same electrolyte is in 1000 liters. Okay? Get it? It's like this. You had 1 cup of rice. You want to feed 100 people. So you add 100 cups of water to that 1 cup of rice. Will it feed 100 people? Definitely not. They'll be having rice soup. But you get the idea what I'm trying to say over here. Okay? So if my concentration is decreasing, concentration क्या होता है? Moles per liter. Number of moles is fixed. So of course you are increasing liters to change the concentration. This implies lambda is directly proportional to volume. Molar conductivity is directly proportional to volume. And volume is basically increasing. So the increase in volume compensates for the decrease in conductivity. Okay? When you are diluting a solution, lambda molar increases because the increase in volume compensates for the decrease in conductivity. This is something that you should keep in your mind. Now I'll just look at the chat box. I'll take your doubts if there are any, then we'll move forward. Okay. थोड़ा सा tricky concept है. It's a tricky concept. It takes a little bit of time to grasp, and I've tried to explain it as best as I can. But if you've got any doubts, then please tell me. I will try to answer your queries as well. ठीक है? I'll get your responses in 10 seconds or something. Rohit, okay, you don't need to spend that much money. Sairam, it is like every day. Okay, I haven't changed anything today. ये वाला कह रहे हो ना? Okay, I'll reduce the brightness so that you can see. एक second, मैं graph के लिए, just so that you guys can see the graph, I will reduce the brightness. Just a second. ये लो. अभी दिख रहा है graph? I've taken it straight from the NCRT. I'll read your chats at the same time. So Chess is asking, I'm not getting these tricky concepts when I study alone. Don't worry, you can study with me over here on this channel. So after I teach you these concepts, make sure you study the NCRT. Read the theory from the NCRT, you will understand it completely. That's my guarantee. Okay. So Lilac, the thing is that the conductivity itself decreases, yeah, because conductivity is conductance for a fixed volume. Molar conductivity is conductance for a fixed number of moles. Do you understand the difference? If I say just conductivity, it is for a fixed volume. In that volume, you are reducing the number of ions, so therefore conductivity is decreasing. Now, molar conductivity on the other hand is conductance for a fixed number of moles, for 1 mole basically. Yeah. So 1 mole is fixed, volume is increasing. Yeah. So that increase in volume compensates for the decrease in conductivity. Okay. That is the idea. Janvi is saying in last class while solving questions we assume that conductance is directly proportional to volume for the same concentration. Is there a logic? Janvi, the definition of specific conductance or conductivity, that is kappa. Okay, the definition for kappa is conductance for a fixed volume, conductance for a unit volume. So since this is conductance for 1 cubic meter, that is why it is proportional to volume. Do you get the idea? This can be thought of as conductance for 1 meter cube solution. That's the logic. If this is conductance for a fixed volume, if you increase the volume, this increases. That is the conductance. Fine. Alright. Sanjana is saying if we dilute, shouldn't the space between the ions increase and hence conductivity decrease? Sanjana, that is what I'll try to explain now. Now, my dear friends, let's try to understand this idea theoretically. Let's try to understand this idea without any numbers. Okay? Trying to understand this idea without any numbers. I will revise for you a concept that we've studied earlier in the equilibrium chapter. एक second मेरे को थोड़ा सा, yeah, increasing the brightness back again so that you can see my face. My dear friends, do you remember alpha, which is what? Degree of dissociation. Alright. Alpha, that is degree of dissociation, increases with dilution. Do you remember this idea? Degree of dissociation increases with dilution. Do you remember this idea? ये अगर आपको याद होगा, for weak electrolytes we had done this, yeah, that if you have a weak electrolyte HA, when it breaks apart, H positive plus A negative, yeah, this guy initially is, let's say 1, finally is going to be 1 minus alpha, this is alpha, this is alpha. So from here यहाँ पे concentration C लिख देते हैं, चलो, fine. If this is the case, then do you remember I could write, do you have space on the page? Yeah, I could write K is equal to C alpha by 1 minus alpha. है ना? I could write K is equal to C alpha by 1 minus alpha, and if the degree of dissociation is very less, I could ignore 1 minus alpha as well. So from here I can see that constant value is equal to concentration times degree of dissociation. So degree of dissociation increases if concentration decreases. Basically, do you understand? So the point is, upon dilution, dissociation of ions is more. Of the ions is more. So when you keep diluting, look at the case of CH3COOH. When you dilute CH3COOH, it suddenly shoots up. Why? Because that 1 mole of CH3COOH over here is not dissociated properly. 1 mole of CH3COOH over here is dissociated completely. Yeah. Over here it exists as a neutral species CH3COOH which can't conduct electricity, but over here, since it is dissociated, you've diluted it so much. Yeah, there is such less CH3COOH in such a high amount of water that it dissolves completely. H positive becomes separate, CH3CO negative becomes separate. Yeah, A negative likha hai uske liye maine, I've just written A negative for CH3COO negative. Since the ions are now separated, of course they will conduct better electricity, isn't it? Yeah. So that is one reason. Okay, that is one reason. For KCl, that reason is not that pronounced. Okay, KCl is a strong electrolyte. At any concentration, it's going to break apart very easily. Yeah, it's going to be almost completely dissolved at all concentrations. So the variation in the conductivity of KCl is not that much. Okay? So for KCl, you can think of the formula Yeah, KCl के लिए you can easily think of the formula that lambda molar is basically equal to your kappa into 1 by C, and 1 by C can basically be written as volume, because in 1 by C number of moles is fixed as 1, है ना? Number of moles is fixed as 1, so concentration can simply be written as 1 by volume. Kappa into 1 by kappa into 1 by C is kappa into volume. Yeah, so lambda molar is directly proportional to kappa and directly proportional to volume. Increase in volume is compensating the decrease in conductivity. So that's the tricky bit, because molar conductivity is some interesting concept. So I try to explain to you theoretically why for strong electrolytes and for weak electrolytes you observe this particular idea, and why is it different for these two? Because CH3COH dissociates a lot when diluted. KCl's dilution does not make a lot of difference. It makes a slight amount of difference. Fine, ठीक है? तो थोड़ा सा difference अपने पास आ जाता है, right? Cool. Pum pararam pum pum. So my dear friends, now is the time for us to discuss the mathematics behind the strong electrolyte case. Okay, so ये KCl का case है for strong electrolytes. Fine. So long back, Debye and Huckel were the scientists who actually tried to do these experiments. So they took different types of strong electrolytes. They took KCl, they took MgOH whole twice, they took NaCl. They took different types of strong electrolytes. Strong electrolytes dissolve completely inside water. Okay, fine. Rohit and Sairam, you can take any other compound. These are specific values for acetic acid and KCl. ठीक है? This basically means weak electrolyte. Okay, this basically means weak electrolyte, and this basically means strong electrolyte. As simple as that. ठीक है? Unknown vulture, can you tell me what do you think is incorrect? I will try to explain it to you once again. अब फिर से एक्सप्लेन कर देगा दोस्त. ठीक है, तो अब करते हैं फॉर स्ट्रॉन्ग इलेक्ट्रोलाइट्स देयर इज अ पर्टिकुलर इक्वेशन that was derived empirically. Do you understand the meaning of the word empirical? Empirical means experimental. Okay, so there is an empirical equation, yeah, that was given by Debye and Huckel, and that particular equation goes something like this. For strong electrolytes, okay, for strong electrolytes, molar conductivity is equal to minus A into C raised to the power 1 by 2. Okay, minus A into C raised to the power 1 by 2 plus lambda infinity. ठीक है? Ajinkya, yes, this is for JEE Advanced as well. Not a problem at all. You can definitely use this for JEE Advanced question solving. Fine. अब ये तो अपने को पता, this is what? This is your molar conductivity. Molar conductivity. Fine. This is what? Concentration. ठीक है? What is this thing? This, my dear friends, is known as molar conductivity at infinite dilution. This is molar conductivity at infinite dilution. Can you see? This is the point of infinite dilution. Yeah, almost this point here. When you take your concentration almost to zero, not exactly zero, almost to zero. So when concentration tends to zero, this is the point which is known as limiting molar conductivity. ठीक है? This is called limiting molar conductivity, that is known as molar conductivity at infinite dilution, also known as limiting molar conductivity. You can denote it with lambda infinity. Okay. Dhruv, it's not blurry. You can refresh the page once. You can check the video quality, increase it to 1080p. Fine, this is what's going on. So weak electrolytes we'll deal with later. Weak electrolytes will be covered with Kohlrausch law tomorrow. For now, we'll just focus on strong electrolytes. So strong electrolytes में क्या चल रहा है? That your molar conductivity is basically equal to some slope. Okay, this is what? This is basically just the slope of the graph. Can you see this graph has a slope? The slope of that graph is this minus a, just a straight line graph. Okay, it's just a constant. What is this constant? Just some constant. Just some constant. Fine. D by Huckel constant. You can call it a D by Huckel constant. Okay. D by Huckel. These guys. You can call it a D by Huckel constant, but hardly do we ever mention these names. Okay? So molar conductivity is equal to minus times this A, which is a constant value, which is basically equal to the slope of this equation, into C raised to the power 1 by 2. Okay? Concentration raised to the power 1 by 2 plus limiting molar conductivity. This is the conductivity at infinite dilution, which for KCl is referred to as this particular point. Fine. Okay, someone is asking, sir, what is the difference between molar conductance and molar conductivity? There is practically no difference. Okay, conductance is the ease of conduction of a solution. Okay, conductance is equal to conductivity into volume, because conductivity is as good as conductance for 1 unit volume of the solution. Okay, that's the basic idea. Alright, now molar conductivity is basically conductance for a solution that contains 1 mole of electrolyte. I'll repeat the statement. Molar conductivity is equal to conductance for a solution that contains 1 mole of an electrolyte. So whenever I say conductivity, whenever I say resistivity, whenever I say molar conductivity, whenever I say this ity at the end, it means that I'm fixing something else. If I say simply conductivity, I am fixing 1 unit volume. If I say molar conductivity, I am fixing 1 mole of the electrolyte. So ity का मतलब ये है, you are fixing some parameter for the main value. Fine, that's the idea. चलो, so ये हो गया idea आपका for the molar conductivity of strong electrolytes. Let's just do a question and we'll understand it better. Again, I've taken this question from the NCERT and this is the last thing that we will discuss in today's class. As I told you in the beginning, I will make these classes shorter. Since we have 5 classes every week, syllabus coverage should not be a problem. Shorter classes will increase the percentage watch time on YouTube and it may be recommended to more people. I'm just trying that out. ठीक है, तो चलो, molar conductivity of KCl solutions at different concentrations at 298 Kelvin are given below. So ये देखो, concentration is increasing, so molar conductivity should decrease. That's exactly what's happening. Okay, concentration in moles per liter is this. Molar conductivity in moles per, S centimeter square per mole is this. ठीक है, got it? Fine. Now show that a plot between ये जो E double dash molar लिखा है, it is basically your lambda infinity molar, same thing. Okay, so show that the plot between these two is a straight line. Also determine the values of limiting molar conductivity. Okay, ये यार इन्होंने थोड़ा misprint हो गया वो इनसे. This is basically just molar conductivity and that is infinite dilutions molar conductivity. They've just misprinted the lambda as this guy. Okay, so show that the plot between molar conductivity and C half is a straight line. That you can do. Determine the values of limiting molar conductivity and A for KCl. How will we do this? First of all, let's remember the equation. The equation says molar conductivity, yeah, is equal to minus A times C to the power 1 by 2 plus molar conductivity at infinite dilution. I can also call this limiting molar conductivity. I'm going very slow because these topics are a little tricky. ठीक है, चलो. तो यहां से first of all, how do we calculate slope? As you guys know, slope is equal to y2 minus y1 upon x2 minus x1, isn't it? That's what the slope of a straight line is, y2 minus y1 upon x2 minus x1. So just pick up 2 points from here. Let's pick up the first point and the second point. So your minus A will be equal to 148.29 minus 148.61 divided by, okay, divided by, this is concentration. We need the root of concentration. So divided by root of 0.000309 minus root of 0.000198. This is your slope. Now I know the calculation is a little weird. I'll just help you with the values of root C. I have those values written over here. Okay. Root of C के values मैं लिख देता हूँ. Root of C's values are कितना है 0.01407, 0.01758. ठीक है, मैं values दे रहा हूँ आपको. Then 0.02283 and then you've got 0.03145. These are the values of root of C. So you can straight away fill those here. कितना आ जाएगा? Can you guys tell me what is the value of A that you are getting? A कितना आ रहा? Can you quickly do the calculation? Aditya, I am glad. Congratulations, man. Mohammed Khan, you can use N Avasthi for physical chemistry. You can use Jaiswal for क्या कहते हैं, inorganic chemistry, and you can use MS Chauhan for organic chemistry. Cool. Siddharth, they better do. I know, they better give you the values of root C. This is just a theoretical question given to you so that you can understand the significance behind this equation. This equation will come in the examinations in a different manner. तो करेंगे. Okay. Chess, the daily timetable is at 7 p.m. we have classes for 11th class students. At 8:30 p.m. we have classes for 12th class students, and classes happen from Monday to Friday. Okay. चलो जी, बताओ कितना आ रहा है, आंसर बता दो यार. मुरली is saying A is coming out as 9116.8. Okay. कुछ ज़्यादा नहीं बोल गया मेरे दोस्त, काफ़ी. Not really bro. Not really. चलो मैं थोड़ी सी कैलकुलेशन करता हूँ. This is 0.32 divided by कितना है वो 1758 minus 1407. And this is the calculation that you have to do. करके देखो. Somewhere around 90 आएगा ना आंसर, approximately 90 है. Approximate करके लिखते हैं अभी के लिए. Forget about accuracy for now. Approximately answer will be 90 है ना. And what will be the units? Of course, the units of A will be matching with the units of lambda. When you multiply with C half, C raised to the power half, A should have units so that it equals the units of molar conductivity, है ना. सो ए का यूनिट क्या आएगा? काफी खतरनाक सा यूनिट आएगा इसका. ओके, द यूनिट ऑफ ए इज वेरी वियर्ड. एज यूनिट इज गोना बी काफी गंदा यूनिट है इसका. दिस इज एस सेंटीमीटर स्क्वायर मोल इनवर्स, ओके, डिवाइडेड बाय moles per liter raised to the power 1/2. This is the unit of A. काफी गंदा सा यूनिट है. So no need to worry about the unit of A right now. It's a very weird unit. Anyway, so this is the value of A that you have. ठीक है. Now that you have the value of A, ये अपन ने determine कर लिया. Let us take any specific point. Let's take this point. ये point ले लो उठा के. You at this particular point know the value of A, you know the value of C raised to the power 1/2, you know the value of molar conductivity. Can you calculate infinite molar conductivity? Absolutely yes. है ना? You can easily calculate infinite molar conductivity by plugging in the values. कहाँ है values? I'll just point them out to you. A is something that we calculated over here. You can take the C half from here. You can take the molar conductivity from here. Fill in these values, you will get this as your answer. Even in the laboratory, this is what we do. We do an experiment where we measure concentration versus molar conductivity. Then we write the root of root of concentration. Okay. फिर क्या करते हैं? We try to fit it into this graph. Once we try to fit it into this graph, we can easily obtain the value of limiting molar conductivity. Do you understand? It's not possible to measure this in the laboratory. How will you reach zero concentration? That just doesn't make sense, right? So this particular value is always calculated from such equations. ठीक है? Ankit will do that eventually, don't worry. Cool. So दोस्तों, सिंपल सी बात है. Let's finish today's class over here. I said I will take lesser time, but करते कराते उतना ही टाइम हो गया है. So we'll finish the class over here today. So what did we do in today's class? Didn't do much, but since the theory was a little tricky, took a little extra time. I still hope you enjoyed the class, even though it was a little more tricky than usual. So what we learned today was that molar conductivity is basically proportional to kappa, and it is proportional to 1/c. Yes. Now the thing is, since we are talking about molar conductivity, my concentration is as good as 1 mole upon, let's say, V liters. है ना? So I can say that lambda molar is basically proportional to kappa into volume. है ना जी? Because number of moles is fixed. Now the thing is that proportionality constant can be removed depending on the units of kappa. Don't need to worry about it. इसको नहीं भी remove करे तो भी चलता है. And we realize that lambda molar increases with dilution. Why? Because the increase in volume more than compensates for the decrease in kappa. Okay, with increasing dilution, kappa reduces, but the volume increases much more, so this product keeps on increasing with increasing dilution. That is the basic idea that we understood today. This idea can also be explained via the Ostwald's dilution law. What was Ostwald's dilution law? Ostwald's dilution law was basically equal to K equilibrium is equal to C times alpha. Yeah, C alpha square. This is what Ostwald's dilution law is. That if concentration decreases, then alpha will increase. Yeah. More degree of dissociation at more dilution. Yeah. So when you dilute a mixture more and more, things dissolve more and more. And because they are dissolving now, the conductivity increases with dilution. Fine. Molar conductivity increases with dilution. Then for strong electrolytes like KCl, I'll write over here, strong electrolytes, we had a particular formula. What was the formula? Molar conductivity is equal to minus A root of C. This A is your slope plus limiting molar conductivity. Fine. This A is basically a constant and it depends on the electrolyte. Okay? It depends on the electrolyte. Fine. Cool. So this is what we have learnt in today's class. This was the summary of it. Now there is no homework question as such. So the homework for you is, please read the NCERT. Now when you will read the NCERT, once I have explained all these things to you, now when you will read the NCERT, you'll realize it's very simple. Okay? So tomorrow's class, which is going to be at 8:30, we will discuss Kohl-Rausch's law. And in Kohl-Rausch's law, we will basically try to see the mathematics for solutions at infinite dilution, and we'll use the same mathematics to figure out the infinite dilution conductivity for weak electrolytes as well. So tomorrow's class is going to be dedicated to Kohl-Rausch's law. Fine. Chalo ji. So Sakshi, this particular equation is an empirically derived equation. Okay? This is derived from an experiment. There is no derivation to this equation. You just do some things in the laboratory, you figure out this is the equation. Okay? As simple as that. So the question that I showed you was a mathematics question. Okay? Lots of values of x are given, lots of values of y are given. You have to figure out the slope and the intercept. That is a question from straight lines. Okay? Cool. Chess is asking how to speed up my thinking process, thinking speed. Simply read the NCERT. Okay. Yash, can you please watch the class from the beginning? Chalo. So people, that's it from my side for today's class. Thank you so much for joining in. I tried to limit the time that we will spend in today's class, but again, couldn't happen. I will try it again tomorrow while doing Kohl-Rausch law. And tomorrow, I think the class will be a little more mathematical, so you guys might enjoy it a little better. Fine. Thank you so much for watching. Thank you so much for joining. You know what to do. If you enjoyed the class, hit that like button. If you want to join Vedantu as a long-term student, links are in the description box down below. Crash course you want to join, links are in the description box down below. And yeah, I'll take your leave. Thank you so much for watching. Take care. Until next time. Good night.